Thanks for watching the screencast. The objective for the screencast is learners will be able to graph the solution to a quadratic inequality in two variables. So we want to graph the inequality here. We want to graph y is greater than x squared minus 8x plus 17. Well, this is similar to the linear inequalities that we graphed earlier in the course, where I'm expecting to shade part of the graph to indicate the part of the xy plane that solves this inequality. Any order pair in the shaded part should solve it. And I think I can operate in a similar fashion. I've got a boundary graph that would be like y equals x squared minus 8x plus 17. So what I need to do is I need to write that, I need to find some way to graph that. Now I would recommend you try to write this in vertex form from Learning Target 14. So what I would recommend you do is to rewrite this in the form that's going to indicate the vertex. And to do that, I'm going to complete the square. So I'll give myself some room in here. This is the part that I'm trying to write. Part of our expression is a binomial squared. And if I need to still sketch out that box to complete the square, I can. I don't know that you necessarily need to at this point. But to complete the square with x squared minus 8x, x squared belongs here. X and x are my two factors that give me x squared. Since I'm making a square, I need to split my negative 8x evenly to negative 4x and negative 4x, which makes these negative 4s. And those negative 4s should tell me what the number is that completes the square here. It's 16. So that's the number I need to add in here. Now, just like we did in some of the work in Learning Target 14, you could do it. I don't really want to think about adding 16 to this side. I really want to think about undoing what I've done here. So if I added 16 on the right side of my inequality, to keep that inequality valid, I should also subtract 16. This and this should undo each other. So I've completed the square. Now I need to actually write it in vertex form. So y is greater than, these three terms here, the diagram shows me would be the same as x minus 4 squared. X squared minus x squared minus 8x plus 16 is the same as x minus 4 times x minus 4 squared. And then 17 minus 16, that's a plus 1. And now this thing is in vertex form. Now I can pretty quickly get the graph made, because I know the vertex is at 4, 1, right there. And from there, and I know this thing is going to open upward because a is positive. In fact, a is 1. I can use my odd pattern. As I work away from the vertex, go up 1, then up 3. The next one would be up 5, but it's off the graph. And let's do up 1, up 3 in the other direction as well. My boundary is going to be a graph that includes these 5 points. So I want to now look at the inequality sign. This is strictly greater than. So instead of making a solid boundary line, I need to make a dotted boundary line. We're just going to make it a dotted quadratic graph line. Best we can. Something like that. And now I'm going to think about which side I need to shade. So I want to think about where the y's are greater than the boundary line. The y's are above it. I want this part right in here. All of the things that are above the boundary line should solve that inequality. So anything in this part of the graph will solve our inequality. Okay, this one's for you to try. Pause the video, see if you can make a sketch of the inequality, and when you think you've got it, hit play to get some feedback. I would strongly recommend you complete the square. to graph this. So let me write it like this. Y is less than or equal to x squared plus 6x. I'll leave some room to actually complete the square. And then my plus 4 belongs here. It's going to be part of the y value of the vertex. The number that completes the square here is 9. Half of 6 is 3, and 3 squared is 9. But if I add 9 here, to keep this inequality meaning the same thing as this meant, I need to also subtract 9. So what I have is y is less than or equal to, this x squared plus 6x plus 9 means the same thing as x plus 3 squared, the whole quantity squared. And then 4 minus 9 is negative 5. So now that I have it in vertex form, I can tell you that this inequality has a boundary with a vertex at negative 3, negative 5. Right there. And again, I know that this is an inequality that opens upward because a is 1. The fact that a is 1 means that working away from the vertex, I could go up 1 and plot a point, then up 3, and then even actually up 5. And that, the fact that it crosses the y-axis at 4 jives with the y-intercept of the boundary line being 4, so that makes sense. And the graph should look something like this. Now this is a less than or equal to inequality. So I want to make sure that the boundary line is solid this time. So there's our boundary line. Where do I need to shade? Well, I need to shade all the y's that are less than or equal to the boundary line. Now, the y's are equal to the boundary line when they're on the line, so that's why we made the solid line. Where are the y's less than the line? Yeah, below it. So we will shade all of the area underneath. All of this. Any part of the graph where the point would be beneath that boundary line solves it. There we go. There's a decent sketch of that inequality. Okay, there's one more flavor of this problem that you need to see and experience, and this is actually directly very much like what your pre-class work is like that goes with this screencast. We're going to work this problem backwards. Here's an inequality. You tell me what the inequality is. And I'm going to model two different ways you could approach this. Okay. So method 1 would be to indicate that, hey, there's the vertex. The vertex is at 1, negative 4. So that tells me that I can write an equation that is in a vertex form. I could say, well, hey, that means that y is something compared to x minus 1 squared minus 4. Can I figure out which inequality sign to use here? Well, it's a dotted line, and I've shaded the things that are below the line. This must be strictly less than. Now, that is a correct answer. If you wanted to make your answer look a little bit more like what you'll see in the pre-class work, you may need to then simplify this and write this right side in standard form. So x minus 1 times x minus 1 is x squared minus 2x plus 1. And then, of course, don't forget the minus 4 here. Or something like y is less than x squared minus 2x minus 3. And that is one way to approach this problem. Now, another approach uses the identifying the solutions of the boundary line set equal to 0, identifying essentially the roots of the boundary equation. So the boundary has, I'll write it out, boundary has roots of -1 and +3. So this approach would say, well, I need to write a boundary equation that says y is, we still know it's going to be y is less than, don't we? And I can pick out a factor for each of the roots that I see. So what factor would I choose for -1? I need a factor that is 0 when x is -1. How about x plus 1? What factor could I pick for x equals 3? A factor that makes the whole factor 0 when x is 3? X minus 3. And now, by using FOIL or some other technique to multiply these two binomials, I can get x times x is x squared. 1x and -3x is -2x. And 1 times -3 is -3. And I hope what you see is that you get the same answer either way you approach this. So there are two different techniques you can use to solve the problems that are a lot like what you'll see in pre-class work. Thanks for watching.